Welcome everyone. Today we start the course Sustainable Management Strategies. And first I would like to introduce myself. My name is Ekaterina Markelova. I'm a double PhD in Earth, Environment and Universe. I'm expert in biogeochemistry and I'm an expert in environmental sustainability. I'm working currently at the company that is called Nanoresonance Industries as the Chief Sustainability Officer. Where we create non-chemical water treatment. We also work with environmental friendly energy production and supervise different environmental projects. And before I continue, I would like to ask you to write in the chat the name of your country, where you came from. South Sudan. Mexico, Russia, Sudan, Uganda. Great. Such a great diversity of geographic locations. Egypt, Uganda, amazing. Well, we are all from different countries, from different educational and scientific background. But today, the introductory lecture will be about the global view. The next sessions, we will move into more business-oriented sustainability. But today we will talk about the global sustainability at the level of country and the level of the globe. For this course, the end of the course is exam, but actually the exam will be part of the tests and a written task that will be spread all over the term. So the attendance at the lectures is obligatory with cameras on and activity in the chat and different tasks during the class. Seminars that you have in your agenda, it will be actually small online tests, and you can use anything what you would like for taking those tests. You can use lectures, you can use online resources. The only two things you are not allowed to use, one is your friends, so it should be individual assignment. And second is not to use artificial intelligence, such as ChatGPTs or similar. Otherwise, I will give you the links for official platforms that you will supposed to use in order to answer those questions. So you don't need to memorize anything. The goal of this course is to demonstrate you the modern concepts and strategies and to make sure that you understand where to find information that you will need. So the final test, which will be exam, it will actually contain some of the questions from the previous tests that you will already take by that time. So nothing will be super new at the end. If you do everything in time, the exam will be just basically a summary of the questions that you will already learn and a small written task. But everything is feasible if you stay in a track. We will have the online platform, Moodle, and there will be your course. Right now it's under development, but I think that next week it will be finished. So all the lecture materials, all the important information will be published there, as well as the tests you will also take on the platform. Some of the information you will receive from me on the chat. We have in your private cabinets, Sustainable Management Strategies chat. But I think since the Moodle platform will be ready, all the communication will be also there. Please write a plus in the chat if you know how to use Moodle or you know where to find it, and minus if you never heard about it. And also please tell me if you are not in this class yet. So I see pluses is really good. We will change the content so it will be ready for your use, because this year program is a little bit different from the last year. But basically I see that all of you know where is it. So you will be updated timely. Great. And talking about the big picture of the sustainability of the business, we can see that development of the business management, how it evolved from the 80s, where we call it business as usual, that the business had an assumption that human and natural or environmental potential is unlimited. So there was concept that business is actually independent from the wealth of the human health or human well-being, as well as from the abundance of environmental resources. But over the time, as you may all heard, we are now facing environmental challenges, so that modern economy adapted the new paradigm where the business is within other ecosystems. So now we see the business is surrounded by the economical ecosystem, so society. Society, it means here any kind of labor also, for example, employees at the company or supply chain partners. So all the people involved in your business directly or indirectly is estimated as the boundary conditions for the success of your business. And at the same time, it's not limited by just human capital. It's now clear that we are all limited on our planet Earth within the environmental capital. And this environmental capital defines if you have sustainable supply of materials. For example, you produce a phone and you need some critical raw materials or metals, and having the mindset that the lithosphere has limited amount of the raw materials makes it clear that your business cannot thrive unless you account for these risks of sustainable supply of the raw materials. And at the same time, it's not only the risk of having sustainable supply, but it also the waste we produce from our business operations. So this environmental concept now is one of the key concepts when we speak about the environmental sustainability. Here you can see also the evolution of the management mindset, where from 50s by the classic economics, the model of Samuelson, which was the first economic model, the business was detached from any other ecosystems. And the next step was the shared value, which is called triple bottom line. So you probably know this famous depiction of the circles of business, environment, and society, where there is some overlap, like a zone inside, which is called sustainability. But this also has been changed, and the most recent model is called system value or systems thinking, where it's not overlapping, but the business is completely within the other ecosystems. And as you may know, this evolution of the mindset brought us to the Sustainable Development Agenda that has this overlapping of environmental, social, and economic paradigms, which should be taken into account in order to achieve the sustainable development of the entire planet as a whole. And there are 17 Sustainable Development Goals that have been also developing from 2000, and they started just as a Millennium Development Goals. There were only about 4 to 9 economic goals. Then in 2012, the most recent Sustainable Development Goals were created that were supplemented by the environmental pillar. Because before 2012, environmental pillar wasn't considered to be important. And nowadays we have this compilation of 17 goals, which represent a combination of economic, cultural, and environmental values. Write in the chat, please, the number of the goal that you have heard before. Maybe you have heard all of them, but maybe write the most popular for you, the one that you know. Just write the number of the goal. Or maybe write minus if you've never heard about this concept. All right, I see someone have never heard about it. Okay. Someone wrote 6, which is clean water and sanitation. That is blamed to be the cause of the COVID because of the poor sanitation. The pandemic was spreading faster than it could be. Those who didn't hear the question, please write in the chat either the number of the goal that you are familiar with, or maybe minus if you never heard about this concept before. All right, I see quite many minuses, and someone wrote 14, life below water. Interesting. Surprisingly, no one writes 13 exactly. Isis just wrote that 13 is climate change. And I think this is one of the most popular or famous goals that you may hear in the mass media. Those who commented, for example, 14, could you please tell us why did you comment 14? Where have you heard about it, or what do you know about it?
So I'm from Mexico. I live in Acapulco, maybe you know the city,
Sure.
near
Yeah.
the ocean. So we have a lot of conservation things for the ocean. Like we try to take care of it a lot. That's why it's very popular there.
And it's been like storytelling as a sustainable development goal as well.
Yeah.
Great. So it's really modern trend when the environmental practices are also raising the awareness about the sustainability development. That's great. All right, and a couple of answers about the climate change. And I guess the rest of the group is not really familiar with this concept. Then I will take some time to give you more background on this, because we cannot talk about the sustainability management of the company unless we understand the global concepts. We will come back to this concept just in a few minutes, but here I would like to show you that the same goals can be represented per groups, like economy goals that contain goal number 8, 9, 10, 12. And the 12 is the most useful for engineers, because I know that most of you have engineering background. So the goal number 12 is about how to improve efficiency of the resource or material use, and how to decrease the waste production. So it's zero waste. And it's basically about the creating secondary materials or optimizing the energy use. Any energy or technology optimization is the goal number 12. Then we have a social group of the goals is 1, 11, 16, 7, 3, 4, 5, 2. And the environmental. Here they are called biosphere. It's 15, 14, 6, and 13. And of course, I would like to warn you that there is no strict separation between the goals, as most of the time, one goal is relevant for all of this. For example, the goal number 6 that someone wrote in the chat is about the affordable and clean water for everyone. On one side, water is our environmental resource, so it is in the biosphere group here. But at the same time, if we don't have good water, we have risks with our health, which is the goal number 3, which is here in the society group. And if we're unhealthy, we cannot work well, which means the goal number 8, which is economy, it jeopardizes the success of our business. So you can see that most of the goals, they're interdependent, and it's really sometimes hard to separate them specifically. Is it relates only to environment, or is it related only to economy or society? But still, sometimes you can see this kind of groups. And the environmental sustainability actually was inspired and was regulated by the concept called planetary boundaries. Please write in the chat plus or minus if you have heard about this concept, planetary boundaries. This is also called safe operating space. And here you can see the representation. So the group of scientists, they have calculations on how much resources we have on our planet to keep us safe. All right, I see so far minuses. And please everyone answer in the chat. We have 10 participants, so I expect 10 answers. Yes, minus if you've never heard, and plus if you have heard about it. All right. So far I see only minuses, and then I will tell a little more. So this group of scientists in 2009, they have published this report. So they have done a global assessment of how much resources have left on the Earth, and what is the population and how we are growing. And they said that actually our era is very flourishing biosphere that creates our life, but it can be jeopardized if one of the environmental categories will be crossed over the limit that we have, because we live on the one planet that has limited boundary conditions. So they set those limits, and one of them is climate change, which is hard to calculate, but still they do it in terms of the carbon dioxide measurements, which is also questionable, but this is what has been used per name. They also set another boundary as a novel entities, and the novel entities, they include, let's say, microplastic. This is something that was not created by nature, but it was artificially designed. What any other materials or compounds do you know artificially designed that were never existed before? You can write in the chat. So all of this is novel entities. Do you know any artificial materials that didn't exist before? Anyone? Well, there are many chemical compounds, even vaccines, for example, or pharmaceutical compounds. They do not originally present in our environment, and we, as scientists, we don't really know how they will impact the environment once they're released. Well, someone wrote ocean, which is very strange answer. Plastics, yes, microplastics, that's I already said. Something else? Maybe some new materials that are used in engineering. Aerogel, yes. As engineers, do you know any materials that are new, like carbon-based or nanoparticles? Those are all artificially created. And since they have been created, yes, rubber, just recently, we still didn't gather enough statistical data how they will impact the environment. So the novel entities is uncertain boundary that accounts for these artificial man-made compounds. Maybe to warm you up, right now it's a good time, write in the chat your name, so I will track who is present at the lecture today. Carbon fiber. Yes, I guess depends on the, yes, carbon fiber, yeah. So please write your name. I will track who attended the lecture today. Full name, please, with last name. Well, I will find you, Gabriel, but the rest, please write the full names. Yeah. All right. So what else do we have? Stratospheric ozone depletion, atmospheric aerosol loading, ocean acidification. If any of you can comment on what is ocean acidification, what is causing it, or why it is dangerous, you can turn on your mic. Anyone have heard about ocean acidification? Maybe someone who wrote ocean before in the chat, that's your time.
Yeah, I think when the pH of the ocean goes down, something like that. I think so.
Exactly.
Because of the carbon in the atmosphere. I think so, I don't remember.
Well, yeah, partially it's because of the balance. When we have too much of carbon dioxide in the air, it comes into equilibrium with water, with ocean, and dissolves in the water. So it may be one of the reasons why the pH is decreasing and it becomes basically acid. So if you imagine, for example, we are drinking fresh water, which is normally the neutral pH, about 7. So acidification means that it turns into acid. For example, when you drink Coca-Cola, this is the acid. So this is a very corrosive environment. And as you may know, some ocean shells, they become dissolving, or corals, they also can dissolve under acidic conditions. We also have biogeochemical flows, and it's about the water quality, but not in terms of the pH, but in terms of the concentration of nitrogen and phosphorus. Does anyone know about the nitrogen and phosphorus, why they're important? As important that they're one of the planetary boundaries. All right, so nitrogen and phosphorus are important because that's what make life. We have nitrogen and phosphorus as well as every cell, every bacteria, and every plant. So when you see that, for example, you walk by the lake, river, or ocean, and instead of beautiful transparent or blue color, it has green or dark brown, it means it's overgrown the algae. And when we have too much of nutrients, and nitrogen and phosphorus, they're the best nutrients, they cause this massive growth of the plants and algae. And when they're growing, they consume all the oxygen and the light in the water that causes all life depleted with oxygen. So the fish start dying, and in general, the water quality is very, very deteriorated. And this is one of the problems in the world, as water in the shore or in the lakes, it becomes anoxic. So there is no life in that water. And it's curious enough that nitrogen and phosphorus come to the water from our agricultural fields, because in order to grow very good crops, we actually put fertilizers, and fertilizers, they're mainly made of nitrogen and phosphorus. So when they're at the perfect concentration, the plants are growing well, but when there are too much, it causes the overgrowth of one plants over another's. So this is dangerous, and we need to control our agriculture in order to prevent these nutrients accumulating in the wastewater that is finally reaching the rivers and the lakes. We have also freshwater use, and this is not about water quality, but about water quantity. And some of you who are from Africa, maybe you know the problems related to just simply not enough water. Can you comment, like if you have heard about the problems that there is overuse of fresh water, that is simply not enough on the everyday basis? I'm not sure if I'm not speaking clearly, but I think I ask very simple questions. If you don't understand me, also maybe write minuses in the chats, but I expect at least some comments. If you can comment on the water related issues. Okay, thank you. Someone please comment if you have ever heard water related issues, scarcity of fresh water. Okay, Finella, lack of water can lead to diseases. But from your personal experience. All right. All right. And I see that not everyone has cameras on. Zezo, Isis, Heidi, please turn on your cameras. This is the requirement. And Musukwa. I hope I read it correctly. Anyway, what else do we have as a planetary boundary is land system change. And as you imagine, this is the deforestation that is called when we cut forest for either biofuel or for a different manufacturing. And also it's the urbanization when we build cities on the places of, let's say, wetlands. We have some comment in the chat that depends, I think, on the country. Only in some countries is where there is water deficiency, must have enough water. Well, that's great to hear, because most of the time when I ask this question, we have some people from different countries and from India, from South Africa. They share that they personally faced the problems when the tap water was limited as 50 liters per day per person. And we don't really count how much water every day we use, but this is quite limited, and the entire countries create the water saving programs. So that's good that none of you has personally faced with these problems. And we have biosphere integrity, where we have the loss of biodiversity at a very fast rate. So as you see by red colors, the biodiversity loss and the contamination of water by nitrogen and phosphorus is something that already overpassed the safe operating space of the survival. So it means that these problems are at the rate that much faster that we are taking active actions. And there are different estimates that just jeopardizing one of the planetary boundaries, we can destabilize entire ecosystem of the planet. So we don't know if it is just one or how one will impact another. So probably we're in the era when the entire stability can be non-sustainable anymore. That's why it inspired the sustainability development. And here we can see the global map, and it is evaluation of how much resources left. And the calculations are done based on the per person living on this country. So for example, it's been estimated that what is the ability of natural resources per population, and it's a simple formula. If it is more resources than people's demand, then it's positive. When it is less than people require, then it's negative and the color is red. So it's called ecological footprint, and it's measured as the biocapacity. And for example, this was all data for 2019 in the world, but as a total overview, we see that from 1965 till 2020, there was a decline. It means that we over-consume the resources that we actually have remaining on our lands. And that in general, if we take biocapacity per person, 1.6, minus ecological footprint per person is 2.6, we have -1 as the average biocapacity deficit on the planet. And we can do this estimate for every country. So now I would like you to interact and each of you to find this map, to find your country, and to write in the chat the total answer. For example, here it is 1.7 and it is biocapacity reserve. Since it's positive, it means there is still some reserve of resources per population. If it is negative, it's called deficit. So I will send you this link in the chat now. And right now, please open the link and find your country, find the total answer, and write, is it deficit or reserve? Okay, you have the link in the chat. And I give for this 2 to 3 minutes. And also in your answer, please write the country. Okay, Mexico, -1.1 deficit. Yes, thank you. Sudan, 0. Interesting result. Okay, South Sudan. Reserve 0.2. Uganda. Uganda, is it reserve or deficit? Okay. If it is minus, please double check. Is it minus or plus? Jefferson. Okay, minus. So then if it is minus, it couldn't be the reserve. It is deficit. Egypt, minus 1.3, the same. If it is minus, it couldn't be reserve. It should be deficit. All right, almost everyone answered, but we still. All right. Please, maybe someone missed the task. Open the link, find your country, and find the total biocapacity. Is it reserve or deficit? We're still waiting for a couple of answers. Hello, hello. We have like 6 answers and we have almost 16 people. Okay, for those who are late, scroll up the chat. You see the link, Data Footprint Network. Go to the link, find your country, and there will be a number of biocapacity. Write the total number. Is it reserve or deficit? Well, the link was okay. Maybe you didn't have it. Here's the link. All right. I don't know why. Please, everyone, turn on your cameras. This is the requirement. And we move on. So most of the answers, they were actually deficit. It means that simply we overconsume as a humanity the amount of resources that is estimated on each specific country. And this has been a global movement to estimate how much resources left. And this concept has been developed and called as the Earth Shooting Day. But before we go to this concept, yeah, here. So for those who joined late, we've been discussing the planetary boundaries as the amount and quality of the environmental resources that serve as the boundary conditions for our biosphere. And then each country can check what is the biocapacity of each country based on the today's information. And most of the time, unfortunately, we see that it's a negative answer, which is red color, and it means that it is deficit, that we overconsume, and that means that maybe for us is enough, but for the future generation, it's not enough. So this concept called the Earth Shooting Day, and here you can see that in general, the humanity in the world consumes about equivalent of 1.8 or 1.7 equivalents of the Earth. So in order to satisfy our own market, we overconsume from what is already limited. And on the right side, you can see the average comparison of the resource consumption by different countries. And we see that average citizen of the United States consuming about five times more than the planet can give. Russia is 3.5, and while India is less than 1. So from this, at least we can see that only India can afford future generations because it actually consumes within the safety boundaries, while the rest of the society is over-consuming the resources. And there is a day that is called Earth Overshoot Day, and it is calculated for every year. For example, in the last 2 years, the Earth Overshoot Day was August 1st or 2nd. Ideally, if we would consume just enough, it would be December 31st. So it's equivalent of 1 calendar year to 1 Earth. But since we're having the Earth Overshoot Day in August 1st, it means that at least we are consuming twice faster than what it's supposed to be. Well, here on the right column, you can see also the diagram, how the consumption is increasing from 1970, where the Earth Overshoot Day was in December 25, 27. It means that it was about the ratio of 1, how much population we have and how much is our demands. But over the last 35 years or 50 years, actually, you see how it is changing, that the population is growing and the overconsumption is becoming faster. So here on the top of the graph, by green color, you can see that August 1st, 2nd, it's where we are now. And since we often talk about the biosphere as the sphere that holds our resources, I would like to remind you that biosphere, it has hydrosphere itself, where basically all water-related lakes, rivers, oceans, it's called hydrosphere. Lithosphere is the sphere where our minerals, our metals, and other raw materials are stored. And the ozone layer, it's also part of the biosphere. So before we move into understanding the total global sustainability of the resources, I would like to ask you, what is the youngest and what is the oldest natural resource that we use for energy production? The most common resources are natural gas, coal, oil, or uranium. And I would like to ask you to fill this questionnaire and to guess what is the youngest. It will be number 1. And what is the oldest? It will be number 4. I will copy this link into the chat. All right, go to the link. And go to the link and make your guess. What is the youngest? Is from 1 to the oldest to number 4 resource that we use. And you have 2.5 minutes for that. All right, someone is answering. 2 minutes left. Okay, and the last minute. those who haven't answered yet. Few more answers. I have only 5 answers, but we are 11 people. Please, everyone, participate. Please write in the chat plus if you answered, and minus if you have not. Okay. We have 4, 5. So yes, 6. Who came late? You just open the link that you see above and you do this test. Also, for those who just joined, please turn on the cameras. This is the requirement for the class. You need to press the button on the test online. I don't know what you need to submit. It's online. I think you already did because I have 6 answers and I have 6 pluses here. So I think you're counted. For those who didn't hear what we do, please follow this link and answer the simple question. You have 30 minutes left, 30 seconds left. Ten seconds left. Okay. Thanks everyone who answered. Let's see results. I'll share the screen. All right. So the oldest seems to be oil, and the rest is about the same. So we don't have a definitive answer. Good guess, but I see that it's something that we don't think about every day. But since we're talking about the global sustainability, it's something that we need to understand. So to remind you about the essential resources that we have, I'd like to tell you the short story history of our planet. But since it is so long as more than 4 billion years, it's really hard to grasp this timeline. So I like the concept that once I learned, it's to imagine that 4.6 billion years is 24 hours. So we can imagine it as the clock, which simplifies such a big scale. So for example, if the Earth was created 24 hours ago, right now it is 24 hours. Let's see what have happened and what resources developed first and last. So At the 12 o'clock at midnight, the planet Earth was created, and it was mainly made of the compressed gases. So it had actually carbon dioxide, uranium oxide, and the very first 5 hours, the atmosphere was extremely toxic and radioactive, and there was no ozone layer to protect us from solar and cosmic radiation. That's why there was no life. And then during 1 hour from 5 to 6 a.m., the land masses started appearing, the continents were forming, and the simple bacteria started forming, as called as cyanobacteria. And this is one-cell bacteria. And what they can do is actually they can photosynthesize. It means that they can take carbon dioxide from the air, and the air was full of this, and convert it to oxygen. So they slowly, they started converting and creating our atmosphere the way we know it today. And it's incredible to think that such small single-cell organisms created such a big atmosphere. But it took them very, very long, counting that there were not that many. 6 hours based on the timeline of the planet Earth. They keep creating oxygen, and slowly the atmosphere was getting enriched. And at some point it was enriched to the equilibrium that the ozone could form and create the protective ozone layer. And since then, the atmosphere became protected from the cosmic radiation. And at 1 o'clock in the afternoon, the single-cell decorates started appearing, and they already contain the nucleus. It means they're more developed organisms, and they could consume not only the gaseous air, but they could also consume the solid materials, such as toxic materials and toxic metals. And by consuming them, they started creating byproducts, which were the biomass created by these microorganisms. So the biomass is actually the byproduct of the toxic metals that microorganisms were eating. And we can call it as a detox of the lithosphere. So till the 5 in the evening, this process was flourishing, environmental detox, where more and more different species were consuming more and more toxicity. They were converting it into the non-toxic biosphere level. And till 10 p.m., this was almost took 16 hours out of 24 hours, which is equivalent to 3 billion years. All life was underwater. And this was due to the water was protecting still from cosmic radiation from the X-rays. And if you may know, in the nuclear power plants, when the spent fuel is used after this cycle, before nuclear waste management, it is actually placed in the cooling pools full of water. Even nowadays, the water is known the best matter that can protect from the radiation. So the same principle was back then, and all life was underwater until the environment became really favorable for animals and organisms to come to the land. And the plants appeared on the land, and this plant created the coal deposits. And the atmosphere that was full with ozone, it was stabilized, and conditions became much more favorable for the life appear on the land. And about 1 hour and 15 minutes ago, dinosaurs appears, and 30 minutes ago the mammals appear, and finally it created the biogas deposits, and still the process of the detoxification was continuing. So the toxic lithosphere was covered by the byproducts of the microbial activities. And these byproducts we call soil, and actually play a favorable atmosphere for us now. Well, the dinosaurs, they didn't live long, only for 1 hour. And then only 2 minutes ago, the ancestors of modern humans appeared. And only 2 seconds ago, the modern people appeared. And within those 2 last seconds, we have explored so much of the natural resources that were hidden in the lithosphere. This is the same concept shown as the pie diagram, which also demonstrates as appearance of the Earth and then the slowly oxygenation. First oil deposits due to the microorganisms from the ocean, and then first coal deposits due to plants on the land, and then biogas formation, while the uranium was one of the oldest radioactive element of the fuel on the Earth. Anyway, during the last 2 seconds, the humanity was able to significantly impact the environment, and just 20 milliseconds ago, the humans started first gathering, which created agriculture, and it accounted as artificial change in the cycle of matter and energy. And about 0.4 milliseconds ago, it was Industrial Revolution, where we started mining a lot of metals and coal from the lithosphere. And now you know that it was very toxic. So once we opened the lithosphere, we released the toxicity into the biosphere. And that's why we have most of the contamination nowadays of the rivers, soil, and atmosphere. And about 0.1 milliseconds ago, we split the atom and created nuclear energy. So having into the account how much impact we've created just since last few seconds of the history of the planet, this complex concept was brought into the Sustainable Development Goals, trying to preserve our resources and preserve our planetary boundaries. And again, the planetary boundary concept, it was developing so that in 2023, from previously 9 planetary boundaries, it evolved into 13. And now when we see the latest calculations, the novel entities, as we discussed, is microplastics, is all human-made artificial chemical compounds and materials. Now it is estimated that the most dangerous zone that already passed the safe operating space for humanity. So we created so much new materials that we don't even know what to deal with them and how to decompose them or how to make them part of the biogeochemical cycle. So this is the most updated version, and as you can see, most of the boundaries already trespassed, and that's why this is one of the motivations to actually achieve the Sustainable Development Goals. When we look into the concept, you can find it online, the planetary boundaries. It has a table that shows the control variables. For example, for climate change, there are 2 control variables. One is a concentration of the carbon dioxide in the air, which is set as 350 as a maximum safe environment. And nowadays, we have 417 milligrams per liter. So this is one of the concept. And the second one is radioactive forcing, is basically the how much of radioactive force has been reflected from the surface back to the space. And ideally it should be 0, or ideally it was like how much comes, the same amount is reflected. But when it comes more, but reflected less because it's being trapped by the surface, it means that the ratio is +1. So you can see that a planetary boundary is +1 watts per square meter, so per surface. And the current value is about 3. That means that the surface is accumulating more heat or more radioactive forces than it used to. So for the test that you will have in 3 weeks, you will have few questions. So you will need to open the website of the planetary boundaries and to understand how to use these tables and to answer these metrics. Another planetary boundary is freshwater change, and there are 2 parameters. One is blue water, and the second one is green water. And the blue water, it means all the fresh water that we use for drinking, for industry. It's the water from rivers and lakes. And the green water is basically water in the precipitation, for example, rain or snow, or its humidity, or it is also the water that is captured by the roots or by the soil. So it is a bioaccumulated water and so forth. So I won't go through all of the parameters here. And during the test, you will have unlimited time, so you will spend as much time as you need to read the questions and to find the correct answers. And for the Sustainable Development Goals, here you have the link, which will be also required for the test. For the UN website, you can go there, and I will send you the link right now, so we will practice how you can read those goals. And so basically, when you go there, you can see, you can select one goal. For example, here I selected the goal number 7 about energy. And when you scroll down, you can see that there are specific targets. And it is important to understand that there are not only goals, but the targets. So these targets, for example, they have here to have some share of renewable energy, or the price of energy. It should be affordable. Or it should be, if you run the manufacturing plant, all your energy consumption should be efficient. So there are specific requirements and targets that you as a company need to understand and report if you would like to create the sustainability report. So right now I'll send you the link for the Sustainable Development Goals. Please open this link. And on the top, you can see 17 goals, right? So you click on the 17 goals and you can see the list of all of the goals. And right now you choose the goal number 7, energy. My computer is a little slow. All right, and here you have a short description of each goal, some facts and figures, and then you scroll to the goal targets. And here you have this list. So for the test, you will be required to understand these concepts, some of the facts and figures, and some of the targets of the goal. Again, nothing needs to be memorized. For now, it's just the practice to understand where you can acquire information when you will need it. All right, and these topics will be enough for you to take the test that will be in 3 weeks. The test will contain the topics of Sustainable Development Goals, as we just have seen. So I will check that you can navigate and understand the targets of the goals. planetary boundaries to understand the parameters and criteria, and the global environmental footprint of a country that we also tested today. So all of the concepts are about the global environmental sustainability. And next week, we will move into the sustainability of the company. Meanwhile, you can have access to these slides of today's class. They will be published on the Moodle platform, and you will have time to be aware how to prepare to the test. For those who joined late, I repeat that the scores, it has exam, but the exam will be basically the compilation of the tests that you will take during the semester. So if you take all of the tests, there won't be surprises for you during the exam. We will focus on all these sustainable development goals. The number 7 was as an example. All right. By this, if you have any questions, feel free to ask. And for those who joined late, maybe you have questions. Also write your full name, please, so I will track your attendance of the lecture today. All right. Well, task for today is to look through the presentation and to start opening the websites to get aware how to use them. But no specific home task. It will be accumulative knowledge until you have the test in 3 weeks. All the information will be available on the Moodle platform and also at the chat. And the presentation will be uploaded there today. So by this, if you don't have any more questions, I would like to thank you for your attention. And in the future, if you have any questions, please feel free to interact with me via Moodle. All right. Thank you. Have a great day. Bye.